Good evening. Today we're going to explore a very important topic in electronics. It's linear power supplies and switched mode power supplies. Part of Unit 5, of course, this electric circuits and electron devices. These supplies are the backbone of almost all the electronic devices. So let's define it and understand how they work. Power supplies convert AC to DC, which can be termed as rectifier. Most of this electronics requires a clean, stable DC supply, and that's where the linear and SMPS designs comes in. Quick check on how many of you have opened a charger before. There are two types. It's linear and switching. Linear is older and simple, while SMPS is compact and efficient, more suited for the modern devices. Here's how a linear supply works. It has a, you can see the block diagram of it. It has a step down transformer. So it's step downs the voltage level. I mean the input voltage will be greater than the output voltage, and we followed by we have a rectifier which converts a AC power into a DC power. Then we have filter to reduce the ripples. Then we have voltage regulator to make the constant voltage, and we will get the required output. Each block has a role and is converting and stabilizing the voltages. In this slide, we'll be focusing on the designing a transformer mains to avoid the magnetic saturation and ensuring the optimal performance. First, the cross-sectional area of an AC of transformer core is collected and calculated by using a formula. You can see this root P of 5.6, where the P is the power required. This helps to prevent the magnetic saturation, which can lead to a core overheating. And depending on the thickness to width ratio, we can have the stack thickness over the center limb width. This should be between 1.1 to 1.5 to ensure the structural and magnetic efficiency. So to remember two steps, we have done calculate of AC for magnetic safety and ensure a proper T power W ratio. And I just want to put a quick question to the class. Why do you think avoiding magnetic saturation is critical in transformer? Type your answers in the chat box. Let's quickly break down how we calculate the transformer parameters like turns per volt, turns per ratio, and currents. All the essential of designing efficient transformer. It's like first we should consider turns per volt. It might be around 10 to 20. For secondary, we'll begin with this formula. Have you seen it is in the display, right? So where the F refers to the frequency, it may be in the range of 50 to or 50 or 60 hertz, where AC is the core area and B is the magnetic flux density, and it's around 50,000 lines per inch. And then we'll consider on turns ratio and the current. The turns ratio, which is nothing but is the ratio of primary voltage by secondary voltage, or secondary turns divided by primary. To find the primary current, the primary current uses the formula P divided by efficient into Vp. For secondary current, we'll use primary current divided by N. Let's have a quick look at the linear IC regulator, which is the tiny power managers found in most electronic circuits. They are PCB mountable, offer precise voltage and current control, and support wide range of outputs. They also come with inbuilt proteins protections like current limiting and thermal shutdown, making them reliable for sensitive applications. And they've been using 7805 and LM31 to maintain the voltage as a constant. Depending upon the application, we may have choose the required one. Then we have simplest and the most used voltage regulator, the three-terminal regulator. There are two families shown here, 78XX series for positive voltage regulation and 79XX for negative voltage regulation. Each has 3 pin, namely input, output, and common. We used to term it as ground. and they have a capacitor C1 and C2 who help with noise and filtering the stability of the output. And we have an boosting current delivery capability where this being used to convert that AC power to DC, and finally which converts the high frequency switch by using a transformer. We'll get this in order to get the DC output they will be using a rectifier, and followed by rectifier will be using a chopper to make get the required DC output. The high frequency switching allows the lighter components and to give a better efficiency. And we'll be seeing on it's like regulated power supply parameters that define how a stable a regulated power supply is. Load regulation tell us how the output voltage changes at the current demand changes, right? You can hope see the formula. Line regulation shows how output voltage varies with changes in the input AC voltage. Then let's talk on output impedance, a small but important concept in regulated power supplies. In Thevenin equivalent circuit, output impedance RSR and SRS appears in series with load resistance RLR and LRL. This affects the load regulation, right? So the output voltage drops more under the load, which is not idle. So low input impedance ensures a better voltage stability. To understand the ripple rejection factor, a key parameter in regulated power supply would be like it's like how well a power supply blocks unwanted AC ripple from appearing at the output, and it can be calculated by using the formula which has been shown there, ripple rejection. The lower the output ripple, the better the rejection. It is meaning that the clear DC voltage is received at the output end. Then we'll compare the linear and switched mode power supplies. There are two key types used in electronics. First, we'll start with linear supply, which is simple. They step down a rectifier, filter, and regulate, but they are bulky and noise energy as heat. Lose energy as they heat. But wherein SMPS on the other hand, which opts high frequency DC using a MOSFET or IGBTs, making them a compact and more efficient. I just want to put a question to the class that which one would you use in a smartphone charger? Type L for linear or type S for switched? There are three common types of switching regulators used in power electronics, namely buck regulator, which can be termed as step down chopper. Then boost regulator can be termed as step up chopper. Then third one we have buck boost regulator. It can be termed as both step up or step down. And we'll explore how to connect the power converters in parallel to the share load. Parallel connection is possible only if the specification permit, right? So as shown here, the converter 1 and 2 are connected with small series resistor zero point 0.1 to balance the current. Rest 3 resistors are prevent one converter from supplying more than its share. So this technique improves the reliability and the load sharing. To wrap up that the linear is great for low noise, low efficiency needs. SMPS is best for modern and high efficiency device. So thank you for active participation, exploring, stay curious and see you in next session. Have a great day.